Good morning all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the video lecture series on block diagram representation in LTI continuous time systems. See empathy, why block diagram, complex systems. First differential equation, complex systems, signal flow and real world analogies. See differential equations means visual clarity needed for differential equation understanding. Complex systems simplify complex systems into manageable subsystems. And then real world signal flow, engineers visualize signal flow for better comprehension. Real world analogies, use real world analogies for system understanding, that is nothing but electrical and control systems. Where do we use block diagram? It is used in electronics, communication system, control system, signal processing, electronics amplifier stages, communication modulation and demodulation, control system feedback loops, signal processing, filter structures, amplifier stages to enhance the signal strength, modulation, demodulation for transmit and receive the information, control system maintain desired outputs and stability, and then signal processing manipulate and refining the signals. This is the definition part. It is the graphical representation of input-output relationships. Here, what are all the elements? Blocks, summing points, takeoff points, flow from left to right. System representation shows the interconnection of subsystems. This is the system representation, takeoff points, summing points, and then blocks. We can go get the signal flow. This is the block diagram representation. System blocks represent transfer function H of S. Summing points add or subtract signals. Takeoff points split a signal to multiple paths. Direction of signal flow arrow shows dependency. Represent system block represents transfer functions. Add or subtract signals is nothing but summing point. Split a signal is nothing but takeoff point. Indicate signal dependency is nothing but signal flow arrow. And then these are the elementary blocks of representation. An integrated is an element used to integrate the input signal. An adder to perform addition, subtraction of signals. Multiplier is used to multiply a signal by a constant value. And finally we can go with your signal processing, that is manipulating the signals. This is the what is mean by block diagram representation is the interconnection of subsystem represents certain basic mathematical operation in such a way that the overall diagram obeys the system mathematical model. See, four types of realization available in block diagram representation: direct form 1, direct form 2, cascade form and parallel form. Direct form 1 is the basic implementation of transfer function. Efficient implementation with fewer delays is nothing but direct form 2 realization. Serious connection of subsystems is nothing but cascade form. Simultaneous operation of subsystems is nothing but parallel form realization. From equation to block diagram, start with differential equation and then convert to Laplace transform. H of s is equal to y of s divided by x of s. Identify individual operations, that is nothing but integration, summing and scaling. Connect them using blocks through arrows. And then system interconnections, cascade, parallel, feedback to obtain the system performance. First cascade, output of one, input of next. Parallel, sum of the individual system output. Feedback is nothing but output feedback to the input. Applications is it is using filter, realization and amplifier feedback. Next one, we can go into testing the block diagram realization. Given x1, h1 of s is equal to 1 by s plus 2, h2 of s is equal to s by s plus 3. Connected in series, h of s is equal to h1 of s into h2 of s. Draw the block diagram with two connected blocks. Show input x of s and output y of s. First, you can define h1 of s, connect in series. You can draw the block diagram. It can show the output as y of s. Next, define h2 of s, calculate h of s. We can show the input as x of s. Next one, testing, reflect and apply. Series combination, we can multiply the transfer functions. Parallel combination, we can add the transfer functions. Feedback loop using standard formula. Goal to obtain the equivalent h of s. Application, it is used in digital signal processing filter structures, control system design. First, we can going to achieve a single equivalent. Combine series elements, combine parallel elements, apply feedback formula. We can going to apply the testing in block diagram representation. Now we can see the assessment. Define block diagram representation. Block diagram representation is the interconnection of such system that the overall system obeys the system structure. List the methods to realize block diagram representation: direct form 1, direct form 2, cascade form and parallel form. In direct form 2, the system function is represented by h of s is equal to y of s divided by w of s into w of s divided by x of s. Where do we use block diagram? It is used in electronics, communication system, control systems, etc. What is meant by multiplier in block diagram representation? Multiply is used to multiply a signal with a constant value. System transfer function is defined by h of s is equal to y of s divided by x of s. Thank you.